はい、プラベース編集長の松本です。今日はですね、アメリカのロサンゼルスの方にやってきました。こちらですね、アナハイムコンベンションセンターというところでございます。こちらでですね、2月に5つの展示会で構成されているものに今回取材にやってきました。私が行くのはプラステックウエストというところが主で今回は取材にやってきました。この5つの展示会はですね、メディカル系の例えば展示会とか、あとパッケージとか、もちろん 3D プリンターとか、もちろんプラスチック系もいろんな企業さんが出展しているということで、大体1600社以上の企業さんが出展をしているということです。で来場者に関しては、大体70カ国以上の方が来られて、3日間で大体1万4000人以上の方が来られるというような展示会でございます。アメリカの西海岸側ではですね、この形状上の展示会では比較的大きいものだというふうに聞いてますので、すごく楽しみにしています。それでは早速取材に行ってみましょう。Hello.
Hello. Welcome to Mack Molding.
Wow. So tell me about your overview of your company.
Absolutely. So we're a full-service contract manufacturer. We're established in 1920, and we have 12 locations and over 3,000 employees.
Wow, 1920.
Been around a long time.
A long time, isn't it?
Exactly.
Okay. So in this trade shows, you guys are focused in medical, or like what kind of things that you guys do service or manufacturing?
Sure. So we focus in medical. That's probably our largest business segment. But in terms of capabilities, we have internal design services, prototyping.
Okay.
We do injection molding with plastics.
Okay.
Sheet metal fabrication.
Wow.
Machining. We do printed circuit boards.
Wow.
And then we also do a lot of assembly as well.
Okay. Well, I can see some this machine here, and you guys actually produce everything, or what guys do you do?
No, great question. So we are very diverse. With this product here as an example, this helps to show you what we do for our higher end assembly. So we make components on this. We source obviously the components which we can't fabricate internally. We'll do full assembly and then full factory acceptance testing on this as well.
Full assembly.
Full assembly and testing, correct.
Wow, wow. This is something maybe used in surgery?
So this would be similar to a dialysis procedure where it'll take a patient's blood, separates the white blood cells, it'll add a drug back into the white blood cells, and then puts it back into the patient.
Okay.
So really complex and an extensive amount of testing required as well.
Okay, thanks. Okay, well, please describe about the prototyping business that you do.
Sure. So we have a variety of prototyping capabilities. So we have additive manufacturing for 3D printing. We have cast urethane. We do machining. And then we also do quick turn and low volume injection molding as well.
Okay, and there are many samples here. So which one is the, 3D printing ones that you guys see?
Yeah, so we have a variety of examples of different 3D printed parts. So internally we have SLA, which is one process, which you'd be able to print, produce parts like this.
Mm-hmm.
We then have FDM, force
TM.
deposition modeling,
Mm-hmm.
which then builds parts layer by layer. So you can kind of see some of
Oh, yes.
this layer build, and we
Yes.
purposely did it on an angle so that you can see what that looks like.
Ah.
In addition to that, we have SLS or HP multi-fusion jet, which you can produce parts which look like this. So you build this in a bed of powder layer by layer.
Okay.
So a variety of different processes.
Mhm.
And then we also have carbon technology, which you can actually make more of an elastomeric urethane
Mm-hmm.
flexible
Wow.
materials here as well.
Mhm. Okay. And how about this one?
Yeah, so this part here is not 3D printed.
Okay.
But what we do is use our 3D printing technology to
Uh-huh.
make a master pattern.
Uh-huh.
And that's a replica of what you're trying to produce over and over. We'll use that to make a rubber mold. And then using a cast urethane process, this is a 2-part urethane, we will produce parts, and then something like this, which you mentioned, we'll then paint and finish, and it looks just like an injection molded part.
Yeah.
The difference is the upfront capital cost is a lot less.
And you said this is the master, I guess.
This is an example of a master pattern. So this
Okay.
would be printed on a large form Stratasys FDM machine,
Mm-hmm.
and we would reuse this to continually make additional molds as needed. Because with a cast urethane process, you could produce around 20 parts depending on geometry.
Okay. All right. Anything else?
In terms of 3D printing, that pretty much covers most of what we do. We also do machining.
Oh,
You
machining.
know, so we'll be able to take blocks of plastic
Mhm.
and then machine those at low volumes where it makes sense.
Okay.
And then we also have just overall low volume injection molding where we can have mud frames. So we can have the outside mold itself be consistent from mold to mold,
Mm-hmm.
but we'll swap out inserts and cores and cavities so that we can quickly change molds out. basically.
So maybe in terms of that, you can actually use the mass production resins for that.
Absolutely.
Is
Yeah,
it?
these are production resins,
Okay.
and they're production quality parts as well.
How fast is it? Like how fast to produce? Like how many parts that you can do for that?
That falls onto the injection molding side. It really depends on the material and the wall thickness. So it would be the same processing time. The benefits of using a mud frame would be the cost to actually make the cores and cavities are less than building it just in a full mold as a standalone.
Okay. All right. What kind of resins are very used a lot? Like PBT, PC, ABS. What kind of things are very common? I don't know.
Sure. I mean, especially from the medical side, you kind of covered a lot of those.
Yeah.
Everything from commodity resins through high-end resins, peaks, IXIFs,
Peaks.
and even Radels.
Okay.
Those are all used as well.
You can produce peaks in that same procedure?
Correct. Yes.
Okay.
Now this is on the mud frame injection molding, not printable in terms of 3D
Of
printing,
course, of course.
but
It's
but
more
exactly.
like an injection 3D, quickly molding kind of thing, right?
it's really using injection molding machines. It's using production style injection molds as well. We're just using some standard external components of a mold to just make the overall cost lower.
Okay, thanks.
You're welcome.
Okay, what's this big parts here? Tell me
Sure.
about it.
Yeah, so this is an interesting part.
Mhm.
So this gives you an idea of a large molded part. For us, we have 125 injection molding machines. We go from 28 tons up to 4,000.
Wow.
And we can shoot up to 50-pound shots. So gives us
4,000.
gives us a lot of
4,000.
capabilities.
Okay.
So large parts, this being one. However, what we did with this is we have a lot of engineering capabilities internally using simulations and just optimization. This panel here, we can mold this in a 1,650 ton machine.
Wow.
So comparatively speaking we also have 4,000 ton presses as well. But we're able to do that by optimizing wall thickness, but we do have a process called external gas assist molding.
Oh.
So during the injection molding process, instead of relying on the tonnage of the machine to pack out the part, we're using nitrogen. So we'll blanket the entire melt on the B side with nitrogen, and that's what we're using to actually pack the part out. Gives a lot of advantages in terms of cost and then cosmetics as well.
Wow. Is this very unique manufacturing process?
This process is unique when it comes to injection molding and the way in which we do it. Absolutely. Big advantages. I mean, on this side of the part, it is two-tone painted, which we do paint internally as well, and then decorated.
I'm just curious that what kind of parts you make for 4,000 tons? A big pallet? I don't know. No, but I don't know. No idea.
Yeah, we can mold some really large parts. For instance, we mold parts for Freightliner trucks, so bumpers, golf cart canopies.
Oh, that's not FRP? I thought that's like a fiber reinforced plastic, like a FRP, but no.
Not in all situations, correct.
Oh,
yeah.
Wow.
So, using some of our technologies, plus with our large injection molding machines, it allows us to be able to mold parts that not a lot of, injection molders can.
You said from 25 tons to 4,000, you said?
28 to 4,000.
Sorry, 28
yeah.
too.
So parts, this big.
I know.
Up to molds, which are much larger than what I can portray right now. Yes, very large.
Which tons of the machines are like working a lot in your company? Like, for example, like I don't know, max to 1,000 tons is mostly, because I don't really,
Yeah, I would say across our portfolio, obviously we can mold small parts to large parts, but our uniqueness comes into our large part molding and then being able to use some of these technologies. So I'd say predominantly for us, a lot of our equipment would be 1,000 ton and larger, because that's where we have a niche versus just other molders.
I see. Because I assume that you can produce all sorts of parts in many ways. So if we actually ask you guys, probably you can, in one stop, you can produce all in, as you said before, assembled as well, and you can paint it, you can manufacture such a big parts as to a small part. So
yeah,
all covered, isn't it?
Yeah, a lot of our customers just appreciate the fact that we have the internal engineering capabilities. So if we can come earlier into the process,
we simulation too, isn't it? Yeah.
Yes, a lot of mold flow simulations. So that's all done internally. A lot of design for manufacturability. But we do have a wide range of capabilities, different materials which we are familiar with, and then also different processes such as gas assist, which we talked about here. You do structural foam, which we can add a blowing agent to the resin and mold thicker parts. So we've got a lot of tricks on our tool belt, which allows us to mold a lot of different parts.
In which kind of industries that's you're good at, like home appliances, I don't know, automobile? What kind of industries that you guys are very good at?
For us, the technologies and capabilities we have really transfers across all industries. As a business, we're not an automotive manufacturer, but across the board, from medical, industrial, consumer products, energy, really you name it, we can mold parts for that.
And do you actually do business mainly in US, or do you actually do exports to some other countries?
So of our 12 locations, they're all in the US, except for we do have one facility in Juarez, Mexico. But we ship parts internationally.
Do you have any business with Japan?
Offhand,
maybe
you probably do, but I just don't know. I just can't think of an example right now in terms of. Because a lot of times we'll ship to our end customer, who will then distribute it from there as well. So inevitably, we have products all over the world.
Okay, thanks. Well, it looks very nice here. This is in like 7-Eleven. I don't know where you can actually get these drinks here.
7-Eleven, yes. So convenience stores, universities, hospitals, a variety of locations.
And so you produce these drinks, or what do you do?
I wish I had milkshakes in order to share.
This is milkshakes, is it?
It is. So this is a commercial milkshake maker or blender.
Okay.
So so this is a good example of leveraging our vertical integration. So leveraging what we do internally.
Yep.
So what I mean by that is this internal metal frame. So this is made internally at Mack.
Internally.
Correct. So we fabricate the sheet metal and then do the assembly of that. All the plastic components we injection mold. So these are cosmetic panels, which we're using that same technology I mentioned over there for external gas assist. our customer didn't want to spend or have extra expense for painting. So by using that technology, traditionally these ribs you would see on the cosmetic surface, we're able to hide those by using that external gas assist process.
This is what kind of resin?
This is a PCABS.
And this housing is also PCABS.
Correct. Yep. So custom color matched,
Okay.
but metal made by us, plastic. There's machine content, and we also do the full assembly and then testing as well.
So like these devices and the pumps and the tubes and things you assemble.
We would assemble all
How do you
those.
assemble? Like you don't have any. I thought you don't have any knowledge or know-how to assemble such a part like this.
We've got some very talented manufacturing engineers who have a lot of experience. And
You need some license to put all in one, or
depending on the industry of the product, yes. It could be UL as an example.
Yeah.
We have to have a certified NSF.
Wow.
It just kind of depends what our end customer requires and what this product inevitably does.
Well, I'm not too sure, so I'll ask. But how many of those milkshake machines are provided all over in US? I have no idea.
There's tens of thousands of these,
Wow.
which are all over the US, but also internationally as well.
Internationally.
Absolutely. Yeah. So when we're manufacturing this, there would be different end configurations based off of where this would be used throughout the world.
And I guess this in terms of the size of tons of the molding machines, this is around 850 under 1,000.
Yeah, it's probably
It's
pretty close. I mean,
isn't
with
it?
our external gas assist process, this would run in a smaller machine than in a traditional injection molding.
Yeah.
But roughly all of these parts can be molded in 1,000 ton or less.
Well, just if you can answer me back, but in daily, how much can you produce this whole set? Maybe you don't do that way, but what's like a production capability, as I say, maybe?
Yeah, so we've got products that might be really complex, even more complex than what you see here, that we might make 10 a year. And then there's assemblies which we will make tens of thousands to hundreds of thousands a year, and then molded parts that would go into the millions. So it really depends on the size, complexity of the overall program.
Well, how long did it take to actually this comes into the market? Like after the customer asked you to produce this whole set, how long?
Yeah, so that depends obviously as well in terms of complexity.
Okay.
Assuming that the design is complete and we're not being held up from a supply chain standpoint, we can establish lines relatively quickly within a few weeks, and then start to do initial pre-production builds while we're working through just validations and qualifications to then release it into the market.
Okay, all right, well, thanks. Okay, well, what's this colorful parts here?
Yeah, so this is a housing for a defibrillator. So what's interesting about this is there's multiple molding steps to be able to produce this part. So what I mean by that, we take it maybe one step at a time. So there's clear windows. So there's 3 clear windows which are molded. They're then hard coated. We will then take these clear windows and put them into another mold, and then do an insert molding process where we're then molding. Let me take this apart, it might be easier to show. So we're then molding this green substrate over the clear. You then take that out of that mold, we'll put it into another mold, and we're going to mold the soft touch outer.
This spot
see
here,
how
right? Yep.
And then there's an additional molding step where on the battery door, we have a gasket which is then molded as well.
Okay.
And to add to that, so a lot of molding steps, but there's also interesting molding processes. Based off the geometry of the part, this is why we have a cross sections. We've got some really thick sections. So you can see how there's hollow sections here.
Yes.
We'll use an internal gas process for these sections where we're pressurizing nitrogen through those areas so that we can get more of a nominal wall. So a lot of insert molding, over molding, and then gas assist in here as well.
So complicated with the many procedures.
Absolutely.
I don't know how much it will be costing. It's
It's not an inexpensive part, but it goes into a very complex assembly.
Yeah.
And a lot of engineering
Yeah.
associated with this
It's
as
very
well.
complicated with complex, and it takes so much time. Like you can't actually produce in one go. You have to do. Wow.
Right.
Wow. Okay.
So yeah, this one's unique.
All right. Thanks.
You're welcome.
Well, thanks a lot for the show. Please have a quickly message to the Japanese viewer.
Sure. Well, thanks for stopping by. I really appreciated it. I mean, it's been fun, and we're able to show you a lot of what we do, from plastic parts to metals to assemblies. So yeah, hope you learned something here. I appreciate it.
Thank you.